All right, friends and neighbors, welcome back to another networking video. This time we're going to follow up on something that we talked about in one of the previous videos, but that was recently, and that is TCP window size and how that works. But this time we're going to talk about what happens when we actually change the window size. So we know that we've talked about window size. We know that it is negotiated at the time of startup, the startup handshake. It's not really negotiated. Both sides tell the other side how much data they're willing to accept. And so each side says, here's my window size, and it doesn't matter whether we're talking about a client server. They both indicate their desired window size. Today, we want big windows, right? Because we have high-performing networks, clients and servers are able to process a lot of data, but there are times when we want to reduce the size of the window, or at least not use window scaling factor. There are actually some low bandwidth connections that are still out there today, so sometimes we want smaller window size, or we actually need them to control congestion. So there is a whole other RFC out there about window scaling factor, right? We know that the window size has a limited, right? There is a limit to the size of the window that we can advertise, 65,000 bytes, but the window scaling factor allows us to go larger than that. But when we start talking about window size, or we start shrinking it, does it actually make a difference? Well, let's find out. To begin with, we're going to introduce a tool that I don't think I've done a video on this for a little while, but it is iperf. And so iperf, I use this all the time for quality of service testing. Some of my previous students have had a chance to fool around with it. So iperf is a very powerful tool and gives you a lot of flexibility in some of the things you might want to test. So let's pull that up here really quick. So here is iperf. So this is where you can go download it. There we go. All right. So we don't need that anymore. I've given you the link in the slide anyway. All the docs are out there too. And it has a man page. So if you want to see the options or you want to look at the docs, you can see that we're going to use just a couple of the options today. And I've also provided the brief description that they have from their website here on this slide. Now, we have a really simple topology today, right? I've just got two nodes. They're two physically separate nodes. They're not VMs in this case. And one's going to be the client, one's going to be the server. And they're just connected via a switch that has gigabit capacity. And what you do is you set up one side to be the server with the -S, and one side is going to be the client with -C. And you tell the client, where the server is. That's really what you do. And then you can specify the time of the test. We're going to use 10 seconds today. And then we also specify the window. Now, there's a lot more that you can do with that, but that's what we're going to do today. Now, there's two things that we want to do. I'm going to do an actual test for you. And we'll look at Wireshark and we'll look at the system output. But this is the command that I'm going to use for the first test. And then we're going to see that we're going to get a transfer of about 825 megabytes. Now, it might be more or less because this is a screenshot that I just did of a test. But let's do an actual test. So what I'm going to do is pull up the server end for you. We'll run the command, and then we'll go over to the client side. So this is a remote desktop connection that I have to the machine that's right over there. And here is the command that I'm going to run. Just going to turn it into a server, and then we'll let the client dictate the specifications. So the server is just going to sit here listening on port 5201, and let's go over to the client. So here's the client window that's on this machine right here. And I've run a bunch of tests, but we'll just up arrow to the one that we want to use right here. This is going to say that you are a client, and you're going to go to 15.62, and the time of the test will be 10 seconds. We'll see how this goes. So right now, we've got a lot of data flowing across the network. We can see the rate of the data going across the network. Initially, it sort of senses what's going on, and then it really spins up. Now, in this particular case, we did 719 megabytes for the transfer, and the speed that we got across the network was 603 megabits per second. Not bad. Okay, so that's very similar, to this test that we got here. But let's take a look at Wireshark. So here is a Wireshark capture. And right here we can see the connection handshake. So the client goes out and tries to find the server. And here is, now we know the flags, right? We got the SYN, SYN-ACK, ACK, handshake, but who cares about that for right now? Let's take a look at that window. So the default window size for iperf is 65,000. It's a good size window, and we'll see what happens initially from the server side. So the server comes right back and says, yep, I've got a big fat window too, and here's my connection. And so they go through the normal connection handshake. Now, as the connection proceeds, we can see from the results that what happened was it started off at a certain level and then really ramped up. Now, in the packets, we can get sort of an indication of what's happening there. Take a look at the scaling factor for the window size. So all of a sudden, the window size sort of changed on us in the middle of the transmission. We can also take a look at the calculated window size here. So Wireshark has given us a hand saying, yeah, the window size is a lot bigger than they might actually have started with. Now we can also get a look at some of the size of the packets. Take a look at the payload, right? Good size payloads here, so lots of data being transported across. So you can sort of imagine what's happening is that large chunks of data are going across the network. The window shrinks a little bit, but then it grows back up again. That's what happens when you have a big window, right? You keep sending data back and forth, and you can see based on our IP addresses that they're having a pretty good conversation back and forth in that they're receiving data and they're acknowledging each other very quickly. Now that doesn't mean even with a large packet or with a large window size that something can't happen. As we take a look over here, we can see that sometimes we wind up with retransmissions because either one side timed out, an acknowledgement didn't get through there, or one side wants to send a lot of data and actually the window did close on us. But we can see with the default window size and with scaling, we get some pretty good performance out of this. Okay, let's try our next test. So the next thing that we're going to do is change the window size down to 1000. Now you know that TCP packets or IP datagrams can be very large in size. Now we also know that we've got to segment that when we send them across Ethernet frames. But the point here is that we're driving performance of the application. And so we know that the minute we send a chunk of data, this window is going to slam shut on us. And so what's the impact of that? Because we can't send any more data until it gets acknowledged from the side that received it. So what we're going to see in this particular test that I ran before was that we went from 824 megabytes to 56.1, right? So a massive drop in the amount of data that was sent. And the speed of the link went down to 47.1. Now, that's not that I changed the speed of the transmission links, right? It's still gigabit links. This is entirely based on the transmission from the clients and the servers, right? So this is governed entirely not by network conditions, but by what the client and server are doing. So let's run a quick test. So this time we're going to run with a window size of 1000. The server is still running over there. Now take a look at the transfer rate. The data that's being transferred is much smaller by more than a factor of 10. The same thing with the throughput. And we see that in this case, we went from 719 down to 50 megabytes transferred, and the speed was 603 down to 42. So absolutely abysmal performance. Let's take a look at what Wireshark has to say. All right, so here is our initial connection handshake. And we can see right here that the window is set to 1000. And here's our SYN-ACK from the server, right? And then as they start to negotiate things, we can see that we're sending, if we get to, here, take a look at our payload. 2 bytes. That is a massive TCP payload. There's 1000, another 1000, another 1000. So it's easy to fill up a packet with 1000 bytes, right? So that's what iperf is doing. Now I should note here that iperf can be an animal. It really wants to send a lot of data. It has good capacity to do that. But here we are really restricting the flow of the data. Now we'll take a look a little bit farther down our packet stream here. Now as we approach this set of packets, we can see that, it looks like things are going back and forth just fine. But at some point, maybe an ACK got delayed. Maybe we had a timer go off. But take a look at what happens here. The window is full. And at this point, it doesn't really matter what either side wants to do. The window is closed and there'll be no accepting of new data until we can get those acknowledgments back out there. And this goes on for quite some time. You can also see that in the space of a 10-second test, there are a lot of packets that are generated. This is 100,000 packets generated in the space of a 10-second test. Well, there we have it. There is the impact of TCP window size on TCP performance. It has a huge impact. And so this is why today we have scaling factor, and we want to maintain large window sizes if we can get away with it, because there's no reason to if your network has the capacity to keep traffic flowing, you're not in a congestion problem, you're not in a low bandwidth condition, and your nodes can do the acknowledgments fast enough. iperf3 is the version that I use today. It's just a fabulous tool. I recommend that you take a look at it and use it for your own testing if you haven't already. And I've got some other iperf video links below that we did previously on the channel. Hey, like and subscribe if I helped. Thanks for watching, and may your packets always reach their destinations. And with iperf3 testing the links for you, how can they not?